Hello and welcome to the projects section of this course. In this section, what I'll be doing is basically I'll be taking a problem statement and we'll be designing a solution for that problem statement. So we'll be designing the sheet metal bracket based on the problem. This will be done by following the guidelines of manufacturing stiffness, durability and assembly, whatever we have studied in the theory section of the course. All that will be followed. And using those principles, we will be designing the sheet metal bracket. So I'll be using the software Fusion 360 and the focus over here is going to be on design concepts. It's not going to be what commands I'm using in CAD, because there are same workflows which are used in all CAD software. There is not that much of a difference, but the concept, the design concept is going to be the focus of this section. How to come up with the design concept and what are the considerations to be made while designing those parts. That is going to be the main focus of this projects section. So we'll be doing 4 projects and we'll be going one by one, and we'll be taking the input data that is in the form of a step file, and those files are already available in the resources section. So you can just download those files and practice them side by side. So we'll be taking that and then we'll be designing the bracket as per the requirement. A brief note on Autodesk Fusion 360. Autodesk Fusion 360 is a free mechanical design software which is being generally used for small companies and startups. It is a very popular software nowadays. It is very easy to use and it has a simple interface. And there are multiple workspaces in Fusion which cover the complete product development cycle of the product. So Fusion 360 is an ideal software to learn mechanical design in, and that's why I've chosen that software, because it's very easy to use and all the commands are very intuitive. So let's start with the project 1. So this is the first project in which we have to design a sheet metal bracket to hold the pin mounted using the holes on the plate. So basically we are having a plate over here which is having 2 holes, and there is a pin which is located over here, and that pin has to be mounted onto the mounting plate using a bracket. So that is what we are going to design. So the first step is to open the step file, which is the reference file using which we will be designing the bracket. So go to the file, go to open, and select the step file, first step file for project 1, and click open. So that is going to open the CAD file which is having the reference data for project 1. Now you can see over here, this is a plate. It is having 2 holes and this is the pin. Now we need to design a sheet metal bracket to join these 2 parts together. Now let us see how we can conceptualize the bracket design. So this is the top view of that assembly. This is the plate and this is the pin. So we can basically design a bracket like this, something like this, and the mounting holes will be somewhere over here. So a C bracket in the top view would be sufficient to serve the purpose for this design. So before we go on to design the bracket, it is important to keep in mind the requirements which have to be met. First thing is the bracket should be stiff. It should have enough thickness so that the bracket is stiff to hold the pin in its place and to not be deflected a lot. Second thing is it should be durable enough to take any loads which are acting on the bracket. So it should have durability. Third thing is the assembly requirements should be taken care. That is, the bracket should be easily be assembled onto the plate using the bolts. So that aspect also has to be taken care. And finally the manufacturing requirements, that is the bend radius, the clearances between the bend radius and the holes and the sharp edges, all those requirements have to be met. So the basic procedure would be to review the input, to understand the input data. That is what we have done. To design as per the input data and the requirements, to conceptualize the design, and then again to review the requirements after the design has been done. So this is the basic design process for any part. Now we'll be going ahead and doing the actual design of the part. So let's start the design now. The first thing which we need to do in Fusion is there are actually two ways of designing. One is with the design history and one is without the design history. When you load a STP file, that is .stp file, it generally is in the default that the design history will not be recorded. But we are making a parametric model, so the design history has to be recorded. For that, right click on the topmost component and select capture design history. You can see at the bottom one timeline is going to come, which is going to show whatever actions we are doing on the part. So with that activated, we are going to go ahead and start the sketch. So we'll be making the sketch on this plane right here, highlighted over here on this plate. For that, we have to select the create sketch option. Go to create sketch. It's going to align the view perpendicular to that plane. Next thing what we are going to do is we are going to hide this pin. We don't want this pin over here, so we are going to hide it. So for hiding it, we can just press this bulb, click this bulb button. It's going to hide the part. And now we can sketch over here. So we'll sketch a rectangle, select the 2-point rectangle option over here. If it's not available over here, you can select it in the rectangle drop down, 2-point rectangle. Click the 2 points of the rectangle to make it. And we need to dimension the rectangle. So I'm going to give it a width of say 12 mm and a length of say 28 mm. These are basic dimensions which we might be modifying in the later stages based on the requirement. Next step is we are going to constrain the rectangle with respect to these two holes. For that, we need to get the projected geometry of these two holes. For doing that, we need to select the geometry over here. So you can see the edge of the hole is being selected. Select the edge of the hole and go to under the sketch drop down, go to project/include. In that, the project option is there. Basically that allows you to project any geometry in 3D space onto the sketch plane. So click on project and it's going to ask you to select the geometry. This is the edge of the hole which you are going to want to project and press OK. So when you do that, you can see in purple color the projected geometry in the center of the hole has appeared. Do the same thing for the other hole. You can press P, which is the hotkey for project, for the other hole as well. So okay. Okay, so the next thing is to constrain the rectangle with respect to these two holes. For that, we need to give dimensions to the side edges. So for example, if I'm giving it 6, I'm giving this from the top as 6. Now over here, the total width of the rectangle is 12. So I've given 6. So it has centered it based on the holes. But for this 28, I need to calculate how much distance I need to give from the edge in order for these two holes to be centered with respect to the rectangle. That is, there should be symmetry. For that, I need to calculate the this length. This 6 mm is what I've entered right now, but I need to actually calculate it. For that, what I need to do is basically 28, that is the total length minus the length between this point and this point divided by 2. So for that, we need to measure the distance between the hole centers. So using the measure option or using the inspect option, under inspect, if you use the measure option, you can measure the distance between the two holes. Select the two hole centers. After selecting measure, you will get the distance 15 mm. So basically now you can calculate what is the difference. 28 minus 15, 13. 13 divided by 2, 6.5. So if you are spacing the hole from this edge 6.5, it will be symmetric. So that's what I'm going to do, 6.5. Now you can see that this has become symmetric. And now if you want to give dimension to this, it will say that the sketch is over constrained. So if you just want to place a reference dimension, not the driving dimension, it's going to place it, but this will be a over constrained sketch. So it might as well delete it. Now the rectangle has been fully constrained. Next step is to create a surface from this sketch we have created. So let's go out of the sketch, press the stop sketch button, and we'll go out of the sketch. Now to make a surface from the sketch, we will need to go to the patch workspace, which is over here under the drop down of the workspaces on the left hand side top. Under patch workspace, we need to use the patch command, which is the first command or the topmost command over here, the patch command. So it's telling us that we can create a planar or 3D surface within a boundary of a specified closed loop. So that's what we want to make over here. This is a closed loop sketch in which we want to make a surface from it. So if we just select patch and select the sketch, it's going to close the whole sketch into one surface. That's it. If you press OK, and if you just hide the other backplate, you will see the surface has been created. So as simple as that. The next step is to create the flange. For that, what we can do is you can just unhide the plate, the back plate, and we will use the modify command under the patch workspace, and under that extend command. So using that, we can select this edge. So it's going to ask us to select the edge. We're going to select this edge, and what is the distance we want it to be flanged, and what is the extend type. So we can select natural, which is going to just extend the natural surface, or we can select the perpendicular, which is going to extend it perpendicular to the base surface. So this is what we want. We're going to press OK. Distance is 15 mm. That can be modified later too. Press OK. So we have made a flange. Same thing for the other edge as well. Press OK. So now we have made the basic shape of the C bracket. The next step is to make the bend fillet or bend radius. For that, we'll use the fillet command under the modify. Under modify, that is the fillet command, select fillet and select the two edges which need to be smoothened out. And I'll be giving a dimension of 4 because I want the bracket thickness to be 2. For that, I need to give 4 such that when we thicken it, the minimum radius on that bend will be 2, which is the minimum required. If it's lesser than that, it's not manufacturable. So for that, I need to give 4 as a minimum outside radius for this surface. We will see as to how that works. So over here, by giving 4, I'm getting one more problem. That is this edge of the fillet and this hole is very nearby. So basically I need to maintain the minimum gap should be equivalent to thickness of the sheet, that is 2 mm. But over here, if I measure this, it is 0.5 mm. So I need to increase this. For that, I can change the sketch, the base sketch which I made of the rectangle, to increase this 0.5 to 2. So let me just go back to the original sketch, the base sketch which we made, and that is sketch 1. So this is the sketch. Now the main dimension over here which is playing a role in creating that gap is 6.5. So I need to increase this dimension. So I'm going to say that I want it to be +2. So 8.5 is what I want it to be. Now the overall length has remained unchanged. So this adjustment of 2 mm I need to adapt to the overall length also. So 2 mm on either side, that is on right hand side 2 mm and left hand side 2 mm also. So that will be 4 mm. So 28 plus 4 will be my new length, and that makes the holes symmetric as well. So that is how we added 2 mm to the gap between the hole center and the edge. Now we can go out of the sketch, and if we see, now the distance has been increased. So the distance has become 2.5, which is manageable, which is feasible for manufacture. So with this we can thicken this surface. So the next step would be to thicken the surface. Create, thicken, under create that is the thicken option, which allows us to thicken the surface. So thicken, and then it's going to add thickness. So for us, we will be adding the thickness outside, not inside, because if we add inside, the material is going to go inside the base plate. So we don't want that. So this direction has to be inward, not outward of the surface. And the thickness is 2. And now we have the bracket. So the next step is to give the holes for the pin so that the pin can go through. So we'll turn on the pin and we will sketch on this face right here. And again, we will use the project command. We'll be using the hotkey P and select the edge of the pin, outer edge of the pin. Press OK. And we are going to extrude this out using the model command. So under the model command, under the model workspace, we have the extrude option. We select that, select the sketch we made and extrude it out. So while doing this, you should make sure that the objects to cut, you're not cutting the pin. You should cut the bracket, that is the gray color bracket. So over here, you should untick the body one that is corresponding to the pin or whatever it is in the file. The body which is corresponding to the pin has to be unticked. So the pin will remain as it is and the bracket will get cut. So press OK. So now we have made the hole in the bracket as well. Next step is to just to chamfer these edges so that they are smoother. So go to modify, go to chamfer and go to modify chamfer, select these edges, all the 4. Control select, control click. You can select all the 4 at once and just move the cursor inside. So that will show us the extent of the chamfer and we want it to be 4 mm. After that, we will just give the fillets to the chamfered edges. So fillet command, select all the edge and give a basic fillet of 2. So that should do it. So this is the final bracket which has been made. Over here we made one consideration, that is we made sure that the clearance between the fillet and the hole is maintained more than 2. And also we maintain the clearance between the hole and these edges to be more than the thickness, 2 times the thickness. Apart from that, we have given enough distance from the mounting edge to the pin such that the bolt can be assembled or the nut can be assembled. So this is the design of a simple bracket. Although there are additional considerations of assembly, for example, the dimension over here, the diameter is generally decided based on the type of fit which is required between the pin and the bracket. So if it is lesser, then there will be an interference fit. That is what is implied over here, because there is no bolting arrangement shown over here. And the other thing is over here there will be generally a dimension, the dimension of this hole, the mounting hole will be generally higher than the dimension of the bolt, because this is a clearance hole and when using a floating fastener assembly we need to have a clearance fit. So those 2 are other considerations for this simple bracket. So to finally review the design which we have come up with, the first is we'll match it with the requirements, whether we have met the requirements or not. Manufacturing requirements, we have maintained the bending requirements, that is the distance between the hole edge and the fillet radius, that has been maintained. The fillet radius also has been maintained to be minimum for the thickness used, and sharp edges have been removed from the design such that there is no stress concentration. Second, stiffness and durability requirements. Since this application is not a highly loaded application, the only thing which matters is the stiffness of the bracket and not the durability or fatigue life of the bracket. So that is already maintained. 2 mm is sufficient for the application. Third is assembly requirements. So we have given 2 holes over here and the distance between the pin and the hole is sufficient for the insertion of the nut. So assembly requirements are also taken care in this design. So this is an example. We will be seeing more examples like this and we can really understand as to how the sheet metal design process goes about. The next step, of course, for the designer would be to send it out to the manufacturer so that the manufacturer will start the design of the tooling and how to plan the tooling for the part manufacturing. So the manufacturing process of this bracket would go something like this. First, the blank will be made. That is the unfolded view of this part. So this will be unfolded. So a single blank piece will be made with respect to these chamfers, and then bending will take place. That is, this bend and this bend will both take place. And after that, the holes will be punched. These two and these two holes will be punched separately. So that is one manufacturing process which is possible for making this bracket.